But there they are. You can ask right now if there are any of which you are unsure. Now, of course, you will notice that the last two questions, and they will come back in a moment, the last two questions did not supply you with a triangle. You had to draw your own. That is what we'll be doing for the rest of the unit on trigonometry. You'll be creating your own triangles. Sage. Yes. In order to do the trig at your level, every triangle you need will be right triangles. Next year, if you take either Pre-Calc 11 or Foundations 11, you'll be learning how to do trig with bigger than 90 degrees. But in grade 10, we only go up to 90. So yes, it is a bit of a hint that every question you do from here on out will have a right angle triangle in it. Heather. Yes, of course I can. Number 12 is not a great question because it requires you to understand where the sun is at 12 noon. So, but the triangle is still, as said, a right angle triangle. There's the ground, green ground, yes? The stake, which I'm going to color brown like the color of wood, the stake will go in to the ground at an angle of 60 degrees to the horizontal. There's the 60 degrees. Where does shadow live? On the ground, yes? So down here will be a shadow of, that's a way too thick a line, you idiot. Down there will be a shadow of the stake. Now, that whole bit about the sun, who cares really? But technically, the sun at 12 noon is directly over you. So it shines down, creating this shadow, which creates this right angle triangle. And of course, you know how long the stake is because it is 1.4 meters. You know the angle of elevation is 60, so you use cosine to find the adjacent. And it is cos 60 equals adjacent, which is where your shadow is, S divided by 1.4. So, of course, it is 1.4 cos 60, and that gets you 0.7. Everybody good? All right. So, excuse me, if you could turn the page over to page 65. This is what we did yesterday. Right here. You were supposed to find the height of 3 objects. I wrote that on the board. And you had to build the clinometer. That was the name of the thing that you built. If you built anything. If you built it successfully, I should say. It is a very rudimentary version of that same thing that surveyors are looking through with the laser beam to the other guy across the street. It's that. So we have questions 9 through 20 is what we're going to work on today. We're going to do some of them together, and then I'm going to let you go along on your own today, and then I have a couple of pages of extra practice you can do if you see fit. There is also going to be a review, of course, and you're going to write one more quiz before you go into your test. So we will begin with number 9, and as Sage said, yes, Satya. Yes, I've said that a million times. Is this the end of a second unit? Will you write a test on the second unit? And as I've said a million times, after every 2 units, what do you write? A cumulative exam. If it happens once in math, how often does it happen? Always. So if I say it once in math, how often does it happen? Always. Got it this time? Awesome. So as as Sage said earlier, we need a triangle. Can't do trig without a triangle. A lot of kids have a lot of trouble doing these trig questions that don't have a triangle already. I really don't know why. There's the triangle. Now, set it up the way the question says. Ike is standing on a soccer field. Where would Ike be standing? Up in the sky or down on the ground? Down on the ground. Pretty easy. There's Ike. Ike is looking up to the roof of the school with an angle of elevation of 30 degrees. Do we ever care about the right angle? Nope. So there's only two other angles. Which one is an angle of elevation? A or B? A. So there's my 30. Ike is 42 meters away from the base of the school. So is this 42 or is the bottom one 42? The bottom one, because he's away from the base. And now you have your triangle. Now you can do trig in 2 seconds, right? I cannot stress this enough. As you go further along in trig, you are going to often use one triangle to solve another triangle. Which means, remember that thing we were talking about going to your calculator less times than you want to, so you can find the right answers without having rounding issues? Now is the time to start practicing that on this page, because this page doesn't count for marks, right? But this only has one triangle, so we don't have to worry, do we? We know how to do triangles. It's always the same thing in trig. You have a theta, and then you have opposite, adjacent, or hypotenuse. That is whatever is important to that particular question. What do we have here? First we have a theta of 30. We have an adjacent of 42. And I need the height of the school. Of course, right here is the height of the school that I need. The school is not leaned over. There's not been an earthquake. We do not measure height on an angle. Height is a vertical line. So this must be the height of the school, which is opposite. And then, of course, I just do the trig that I already know how to do, which is tan 30 equals opposite x over 42. Now, a great many of you will stop there and go to your calculator because you know what you're doing. I cannot stress this enough. You want to start writing down the next thing. Because as we go further and further into trig and there's more and more triangles involved, each time you go to your calculator, you're going to get lost. I'm not putting you down. You're going to get caught up in what's going on and you're going to be like, did I do this? Did I do that? Whatever. I don't know. So I really, really, really recommend that you actually write 42 tan 30 there. So you know what you're doing. Because if we had another triangle here that we were going to use, this value is what we need. But all of you will round that value off. And once you round that value off, you will change your final answer. Which for me isn't a big problem. But I am not every teacher you're ever going to have in math, am I? So you better be ready and willing and able to do this, for lack of a better word, right. Does everybody understand what I am saying? For me, you give me that number, you round it off, you use that rounded off number later on, I will figure it out. I will put in that effort for you. I cannot guarantee all your future math teachers will do so. Okay? And let me add this to the argument. If you plan on going off to university and doing any math there, multiple choice tests at universities never show the right answer. They give you 10 choices that are all close to the right answer. And you must choose the closest without the right answer ever being on the page. So the more often and the more exact you can get now when it doesn't really matter, the better off you will be later on. Does everybody understand what I am saying? Cool. And you will punch that answer and you will get it. I'm not even going to punch it in right now because this is what is important to me. If you can get to there, you know what you're doing, you know how to do trig. To get this right answer, it's a calculator issue. And I've shown you how to use your calculators about 100 times. So if you haven't figured out your calculator yet, I don't know what to do because there's only 2 options for how to work your calculators. And if you haven't figured it out, I I don't know what to do. So you can all punch that in and tell me the right answer and we'll move on. What is it? 24. Exactly?
No, 24.2.
24.2. Okay. If your calculator says 14 square root 3, then you will, that's not a number that means anything to me, is it? So you need to push that button that has usually S, arrow, arrow, D. That's what I want, the real number. All right. Now, next question, slightly more difficult. But what am I going to need? Triangle. Now, can you draw the triangle right now? If you want. Or you can read the question first and then decide. Most of you are probably going to draw this triangle. Or the other side, right? Or you're going to draw this triangle. Either way, you're going to be able to work this out. It's not complicated. Abby is flying in an airplane at 2,500 feet. Where are airplanes? In the sky or on the ground? Up in the sky. So here's Abby up here in her plane. Agreed? How tall? How far up in the air is she? 2,500 feet. Is the hypotenuse 2,500 feet or is the vertical leg 2,500 feet? The vertical leg is 2,500 feet. She looks down to the ground and she sees the town of Mission. Where is the town of Mission? Floating in the sky like in the Jetsons? No, the town is on the ground. Mission. Now, here's the problem if you drew the triangle before you read the question. How does she see the town of Mission? She sees it in an angle of depression of 15 degrees. Do I have an angle of depression in that triangle the way I have drawn it? No, I do not. So I need to actually know something about math. I need to know either that I should have drawn the triangle this way, and then where would be the angle of depression? Top left. Right here would be my theta. But if I drew the triangle wrong, and I know anything about math, what is that? That is going to be the same value as theta, because the angle of depression from up here is always equal to the angle of elevation at the other end, both of which have been shown to you in previous notes. Right? So you could either use the red or the pink triangle or the blue triangle. Some people will say, well, Mr. Myers, I can't use the pink triangle because I only have one piece of information with the pink triangle. I only have a theta, but that's not true. Because if this is 2,500 in a rectangle, what's this? 2,500. And now I have my two pieces of information for both triangles, right? Now the other problem with this unit is a lot of people forget the difference between the word vertical and horizontal. None of you are those people, are you? Horizontal means what? This one, like a horizon where the sun goes down. Vertical means up and down. Diagonal has a lot of different names for it. All right, so we need to find this value or this value if I'm working on the pink triangle. Is it going to matter which one we do? No, because I have theta of 15 in the blue triangle. Opposite is 2,500 and adjacent is x. And is that not the same thing in the pink triangle? So it doesn't matter which one I use. And now we're back to the same thing we've done about 150 times. What uses O and A? Tan 15 is O, 2,500 over x. Unknown on the bottom, 2,500 divided by tan 15 equals. Now, some of you are still forgetting when to divide and when to multiply. That goes back to like grade 5 algebra, right? Your big problem is this tan 15 bothers you. But all you have to remember is it is the same as this. 20 over x. How would you solve that? Because tan 15 is just a number, just like 10 is just a number. The only thing that's weird about writing it here is you don't know this value. But what does know this value? Your calculator. Right? So of course, if you can do regular algebra, you can do trig. If you can't do regular algebra, that's why I got X blocks. Okay? Pardon me? The value of tan 15, I don't know. The value of tan 15 is going to be 2,500 divided by whatever X is. Because I too do not have them memorized because there's no need. My calculator knows them. Now, back in the day, like when your grandparents were doing trig at school, they didn't have calculators. They had a chart. And the chart had every decimal for every degree from 0 to 90, sine, cos, tan. And they had to put the decimal there and then do this work. 2,500 divided by point whatever it is. Their calculator wasn't there to do it for them. Everybody cool? And what is the answer? 9,330.1. Yay! Number 11 is a very difficult question. Because again, it's tough to read. All of you are able to read that first sentence. The problem with that first sentence is a great many of you do not understand that. The part that is highlighted green. If a road is rising, what direction line must I draw? Vertical, horizontal, or diagonal? I must draw a diagonal line. Now, the road rises 1 meter for every 19 meters measured along the road. Where is the 1? It's vertical because the road is rising, yes? 1, which makes this right angle triangle, right? Now here is where everybody screws this up because automatically 99% of my students put the 19 there. Is that right? Of course not. Does a car drive into the middle of a mountain and take an elevator up to the top? No. The road goes up the side of the mountain. So there is the 19. Again, it is not a mathematical thing. It's a I know how to read and make sense of things thing. Now the next question says, how far does the car travel horizontally when it travels 300 meters along the road? So I have a new triangle, yes? What do I know about this triangle? I know that this is 300, don't I? It is a scale diagram. We could solve it with that thing we did on the very first day where we make the fractions that you learned how to do in grade 9. We could also solve it with trigonometry, couldn't we? Because in this question, I can find theta, can't I? What would I use, sine, cos, or tan? Sine, opposite and hypotenuse. And if I know that theta, do I automatically know red theta? Why? Because it's the same road, right? So if I know this theta, and I want the horizontal measurement, which is right there, here I use sine, here I use what? Cos. If I want to do it with trig. If I want to do it with similar triangles, what's the fraction that I have that I can use to compare? I could use 1 over 19, but then I would have to compare y over 300. And then once I had y, I could do Pythagoras over here, right? What is another fraction I could use? What are the corresponding sides that I have information for?
Opposite and hypotenuse.
I have the hypotenuse in both. So I could do 19 over 300 and compare that with 1 over y. And again, I could find y and do Pythagoras. I could also do Pythagoras here. Find this number, which would be z. And then I could do 19 over 300 equals z over x. And I could do that. The problem with these questions, there's so many ways to do them. I could show you them all, as I just did, but it would take forever. Who needs to make this choice? You do. Do you have all the tools you need to solve this? Yes, but you have to decide how to solve it. Go. And there's a reason I'm getting you to do this by yourself, because you're going to get a really weird answer. This is the distance I am seeking. The highlighted distance. Now, ladies and gentlemen, this is a unit on trig, right? So I am going to use trig to solve this. Whatever you used, you're going to get the same answer if you did the math right. Everybody cool? But because this is the trig unit, I'm going to use trig. Okay? Okay. And what do you get for x? No, you don't. This is the exact problem with this question, right? There's a reason I've given you this question, because almost all of you are going to say 300 here. Is that possible? Why? Because the hypotenuse is 300. So your answer has to be shorter than 300. So you cannot round to the nearest digit. You have to round at best to the nearest tenth, which is 299.6. And again, this is the type of question that I like to give to see if you actually get what's going on. Pardon me? Yep, if you do Pythagoras for the smaller triangle, you're still going to get 299.6. Watch. It's the square root of 19 squared minus 1 squared, right? 18.97, yeah? So that's the smaller triangle. Agreed? So then you had to take that and do the comparison thing, right? So you would have had 19 over 300 equals 18.97 over x, right? Now, so 18.97, since I need 18.97, I'm going to leave it on my calculator, right? Before I go to my calculator, I'm going to set up what I need to do, which is 300 times 18.97 divided by 19, right? So I go back to my calculator. I've got the 18.97 right there, times 300 divided by 19, 299.58, 51994. If you round this off, you're not going to get the right answer. This is why I make such a big deal out of it. Everybody cool? All right. Now, let's say you actually write 300 there. Do I take away all your marks? You showed me all the work. Do I take away some marks? Yes, because can that distance possibly be 300? No, it cannot be. Therefore, you cannot give that as an answer. Everybody understand? Right. Which? How I got what? I used sine of 1 and 19 to get the theta. And then I left that on my calculator. That's why I didn't write anything here, because I know theta is this big long decimal. And I left it on my calculator screen without rounding it off, so I would get the right answer. All right. What do I need to find the area of a rectangle? I need length times width, correct? Do I have either of those things? No. No. Where do length and width live on a triangle? Width, length. Do I have either of those? No, so I must solve for them, yes? What do I have in this triangle? I have a theta of 21. I have a hypotenuse of 12.7. What do I need? Once I have theta set up here, what do I have? Or what do I need? Sorry. I need the opposite, which equals W, and the adjacent, which equals L, yes? So now I just do my math. What uses O and H? Sine 21 is W over 12.7, yes? What math am I going to do there? 12.7 times sine 21. That gets me W. What do I do for L? Cos 21 equals L over 12.7. 12.7 cos 21 equals L. Now, are either of those the answer to this question? No. So should I bother going to my calculator for either of them? No, because they're not the answer to the question. The answer to the question is length times width, yes? Well, there's my L, there's my W. So to answer the question, I need to do 12.7 sine 21 times 12.7 cos 21. Now, if I have a forward calculator, that's super easy, isn't it? What do I punch in? Just like that, 12.7 times sine 21 times 12.7 times cos 21. All right, you five, no, Ethan, you can stay. Malik, this is your desk for a while. Get your stuff and get up here now. Crab, that's your desk for a while. Get your stuff and get there now. And Tajveer, that's your desk back in the corner. Get your stuff and get there now. You got 5 more seconds or you're leaving the room. There we go. And of course, if you have a backwards calc, you must reverse this. Yes? So you would just reverse it. 21 cos times 12.7 times 21 sine times 12.7. But again, it is up to you to know how your calculator works. And the answer is, of course, nearest tenth of a square meter, 53.96 it was. So what would it be? 54. Now remember, if you're going to do this right, 12, and your calculator puts these brackets in, you must remember to do what right here? You must remember to close the bracket times 12.7 cos. Oops. 12.7 cos 21. Now, remember, some of you don't need to close this last bracket, but you should be in that habit. And there's your answer. Absolutely correct. Nathan.
What you're trying to say is instead of using L and W, it's putting
Yes.
To get more accurate.
Yes. The less times you go to your calculator, the better off you will be.
So that's how you get the number of ones you know not using, right? Putting decimals as opposed to and then total.
Yep. I can't force you to do it, but if you start, you will find you will A, always get the answer I get and never sit there going, did I round it right? And B, as the calculations get more and more and more complicated, and you got to do 15 of these on a page, you'll be better off. Also, it will triply help you because it will help you figure out algebra, which is then useful when you take chemistry or physics further along. But again, it is totally up to you to make that decision, how you wish to proceed. Now, I am going to do 13 with you, and then I'm going to let you go, but I'm going to make a couple of reminders of future questions. So let's have a look at 13. Where is side MN? It's on the far right. It's over here, right? M to N. Which means it's part of this yellow right angle triangle, correct? To find MN, how many pieces of information must I have? 2. I need either 2 sides or a side and an angle, correct? All right. What do I have? An angle. Now, which means I need either this green side or this purple side. Which one can I find? The purple pinky side. Why? Because over here, I do have 2 pieces of information, right? I'm going to use this triangle to figure out this triangle. And this, ladies and gentlemen, is, again, a real-world use of trigonometry. It's not like in the real world there's triangles drawn around on the ground. But in the real world, you do sometimes need to measure things that you cannot actually measure. If you're in a pipeline under a highway, you don't stop the highway so you can run across the street with a measuring tape, right? You do not dig the hole, measure it, fill the hole in, then go tell the pipeline people where to put the pipe. This is what they do. Stuff like this. So, what do we know? I got a theta of what? 33, and I got a what? And hypotenuse of what? 8.2. And I need to find what? The adjacent, which is, I don't have anything for it, so I'm going to call it x. What's going to find me the adjacent? Cosine. Cos of what? 33 equals what? X over 8.2. So what finds me x? And that will give me an answer, won't it? Will it give me a nice tidy answer, or will it give me a bunch of garbage decimals? Bunch of garbage decimals, which we automatically want to round off, yes? When we round off early, what does that do to our final answer? It messes it up. In real life, are we allowed to come up with an answer that is close? No. In real life, if you're digging a hole under a highway, you better do it right the first time, right? You don't get to dig the hole and then decide later. I'll give you another example of this in real life. In your people's lifetime, they dug a tunnel under the English Channel to run a train under there, right? Do you think they dug the whole tunnel, filled it in, came back up to the top, hey man, we totally worked it out, and then redug the tunnel? No, of course not. They did all the math first. And when they did all that math to go under a 30-mile crossing under the ocean, when they punched through the hole, they were this far apart. The English guys were able to put their arm through, the French guys put their arm through, and they were able to shake hands, is how close they were able to work it out. Why? Because they weren't rounding all the way along. Everybody cool? Everybody understand? So, am I going to punch that into my calculator right now? Am I going to? No. Most of you probably are. Is that okay? It is. But you'll be better if you start learning. This is my x. But what is it in the yellow triangle? That is my h in the yellow triangle, isn't it? Now, in the yellow triangle, do I have a theta? What is it? 49. I have an h. What is it? It's x, which is 8.2 cos 33, right? And what do I need? I need an opposite, which is my mn. I'm going to make that y. What uses O and H? Sine of 49 is O, y over H, 8.2 cos 33. What do I do there? Multiply. So 8.2 times cos 33 times sine 49 will give me y. And that will give me my best possible answer. It is 5.2. Now again, If you did all this math separately with very tiny numbers like this, 5s and 8s, you'll probably get 5.2, right? But what if you're digging a tunnel under a 30-mile stretch of water? That little bit you're off over 5 inches is no big deal. Multiply that 5 inches by how many times you're going in 30 miles. Does that little decimal difference matter? Of course it does. Right? If I'm going to shoot a laser beam to the moon and I miss Sam by 1 millimeter, no big deal. But by the time I get to the moon, how far is that 1 millimeter? A lot. Everybody understand? All right. I'm going to shut up. I didn't give you any breaks today. I talked right through. Normally, I'm trying not to do that. So, 67, 68, and 69 is your work for this class. If you are comfortable, that's great. 70 and 71 have more practice work. Tomorrow you will be starting a review on trig that is 4 marks. If you are still dodgy, you'll want to do some of the work on 70 and some of the work on 71, which have the answers, before you start attempting stuff for marks. Everybody understand? Excellent. Also, I want to give you a quiz on trig. We will be doing that first thing tomorrow. You'll do the quiz. You'll finish the day working on your review, which we will be marking on Thursday. Right? Okay, now, before you actually go off on your own, there's a couple of things I have to talk about. Number 15, GHJ. A lot of kids have trouble reading angles that way. What does that notation mean? Where do I start? G. Where do I go? H. Then where do I go? J. I need that whole angle. Okay? That's what that means. The next problem. Number 16. I took this off of a provincial exam. It uses this phrase, 2 guy wires. You may not have heard that phrase, but you know what it is. If you look at like a cell phone tower or a radio antenna, you see them, they stick up in the air. They got a little light on top, right? Looks like this. And they've got wires going into the ground. That is a guy wire. It holds the thing up in the wind. So you can sort out how to draw it, but you needed to know what a guy wire was. I don't know why they're called guy wires and not gal wires. I don't know why they're called guy wires and not guide wires, which is what I thought they were my whole life until like grade 9 when I said guide wires to a teacher, and the teacher was like, what are you talking about? You know, those wires that hold up towers. You mean a guy wire? And I was like, oh, sorry, Mr. Voth. And then he got mad at me. I like Mr. Voth, though. He's a good guy. And number 17 and number 19, when you read them carefully, you will figure it out. But I will give you a hint. You need to draw 2 right angle triangles to figure it out. Okay? Okay. Go.